Good morning to everyone. I am Shilpa. My topic is about first come first scheduling simulator. So the introduction is it is the simplest non-primitive CPU scheduling algorithm. Its goal is to design and implement and evaluate an first come first served simulator using dynamic arrival and burst time. Next is experimental setup. Here the programming language, the simulator was implemented in C. Programming language relations. I was chosen the C compiler, C language for executing code, and tools I had used is online C compiler. The rationale is that these tools provided a lightweight platform independent environment for writing, compiling, and debugging C programs without requiring a logical instruction. Its dataset characters are three different input dataset designed to evaluate the FCF first come first serve performance under various workload conditions. Each process in the dataset was defined by process ID, arrival time, and burst time. In process ID, it is a unique identifier. Arrival time, it is a time. It takes the time that process enter the ready queue. First term, it requires CPU execution time. First dataset is uniform arrival pattern. Its purpose of analysis is to analyze first come first scheduling performance under predictable stable load. Second dataset is about its workload is bursting heavily and arrival pattern. Purpose of analysis is to observe waiting and turnaround time in by the concave effect. Third dataset is it's a real time like mixed load. Its working purpose is to test its FC first come first served can meet response time requirement in a time sensitive workload. Next is implementation. The implementation of first come first served scheduling simulator follows a standard set of steps to calculate the execution matrix for a dynamic set of process, and it is the core of a simulator involves ordering process by arrival time and then sequential calculation completing turnaround and waiting time. And here are the problem statements and inputs of it. And here is the solid Gantt chart. Next is code. The program uses arrays to store the attributes for up to 100 process. It implements the first come first served CPU scheduling algorithm. It dynamically accepts process parameters and calculates the key performance matrix of CT, TAT, and WT. TAT means it is a turnaround time, WT means it is a waiting time, BT means it is a burst time. Its input handling is it gets process count. The user is prompted to enter the number of process. Next is input loop. A loop for loop runs for from I 0 to I less than or equal to n to gather data for each process. Data collection inside the loop, the PID is set and the user is prompted to enter a arrival time and burst time for the current process. Next is output. Here a table here it's showing all the calculated matrix is printed. A loop iterates throughout all process to print their collected and calculated values PID, AT, BT, waiting time and turnaround time and calculated time. So next is observation. Here it across all datasets, the waiting time was heavily influenced by the presence of long process at the front of the queue. Here dataset is moderated burst time. When process had moderated and similar burst time, the average waiting time remained comparatively low and stable. The convey effect, it means dataset 2 when the process had a significant longer significant longer burst time than the other. Caused the well-known concave effect. Its turnaround time followed the same pattern as a waiting time, and uh, it is a simple the waiting time plus the burst time. Next is comparative evaluation. The comparative evaluation analyzed the performance of the first come first scheduling algorithm across the three devices datasets, focusing on the average time and average turnaround time. And here is the complete comparative evaluation table. Its result is to perform matrix clearly by illustrating the dependency of first come first served on the length of the process arrival earlyly. Its best performance is dataset 2 first come when burst time are small and similar. This minimizes the cumulative wait time for subsequent process. Dataset 1 and 3 are has burst time, grow the waiting time, increase sharply. Dataset 3 suffered the most due to long initial process when severely delay all subsequent process. Uh, a well known as the concave effect. The process at the head of the queue focus later process to wait for it completely execution, regardless of how short their burst time are. Thank you.